What if a fan wasn't just a single fixed device, but a modular system? This is MM-Fan Gen 1, a DIY fan platform built from separate modules, PC fan hardware, 3D printed mechanical parts, custom PCBAs and a simple control interface. In this first devlog I want to show you what this project is, why I started it, how the modules work together and how the whole system is documented on GitHub. Hi and welcome to my channel. This channel is about designing and documenting a modular fan system from scratch. The idea is not to build just one finished product, but to create a development platform that can be modified, improved and rebuilt over time. The complete project structure, documentation, CAD files, PCB files, BOMs and firmware are organized in a public GitHub repository. The motivation behind this project was simple. I wanted to build a fan system that is quiet, modular, energy efficient and visually refined. The starting point for the design is a PC and gaming fan hardware. These fans are developed in a very competitive market, so they are usually optimized for low noise, low power consumption and high airflow. But a PC fan is normally designed to move air through a case or a radiator or a filter. A room fan has a different job. It should create a focused airflow that can actually reach further into the room. So the challenge was to adapt the good properties of a PC fan hardware to the use case of a room fan. MM-Fan Gen 1 is built around interchangeable modules. The current system consists of three main modules: MM-Base, MM-Air and MM-Tri. In addition, there are system parts that are not assigned to one specific module, such as MM-Connect and the connection cables. The goal is to keep each part understandable and replaceable. Instead of hiding everything inside one closed product, the system is split into functional building blocks. Let us start with MM-Base. MM-Base is the base and control module of the system. It provides the main electrical control interface, power distribution and the user interface for the fan setup. For Gen 1, the main PCBA uses an Arduino Nano. I choose this intentionally because it keeps the project easier to understand, easier to modify and easier to rebuild. The user interface is very simple. There's one push button to switch between PWM levels and 4 RGB LEDs indicate the currently selected level using different colors. MM-Base is intended to be powered from a suitable 5V USB power bank. The enclosure is designed so that smaller power banks can be placed inside the module. This means the system can be battery powered without using a custom battery pack. After use, the power bank can still be removed and used for other things. The second main module is MM-Air. MM-Air is the fan and airflow module of the system. For this Gen 1 prototype I chose a Noctua NFA12 120mm fan because it offers a good combination of low noise, low power consumption and a high airflow performance. In theory, other comparable 120mm fans could also be used. However, they should provide a similar level of static pressure because the 3D printed shroud reduces the outlet cross-section and creates additional flow resistance. The shroud helps increase air velocity and creates a more focused airflow for use as a room fan. On the side of the module there's an interface PCBA. In this setup it is used because the selected Noctua fan does not provide its own daisy chain connection. The board connects MM-Air to the system wiring and provides two RJ45 style sockets for the connection cables, as well as one PC fan header for the fan. MM-Tri is a tripod module for the freestanding configuration. The name comes from the three-leg design. A tripod is mechanically simple and stable because it avoids overconstraint and can stand securely even if the surface is not perfectly flat. The module is intentionally minimal, it is not meant to be visually complex, but it should still look clean and elegant. The system can currently be assembled in two main configurations. The first one is the table version. In this setup, MM-Try is not required. The modules can be stacked or they can be placed separately, for example to the left and right of a monitor. Because the modules are connected by cables, the layout can be adapted to different desk setups. The second configuration is the stand version. In this setup, MM-Try is used as a support structure, creating a freestanding fan setup. This modular approach is one of the main ideas behind the project. The same modules can be reused in different physical arrangements. Now let's go back to GitHub for a moment. The complete project is documented in the GitHub repository. The README is the main entry point and gives you an overview of the system, the modules, the build configurations and the current project status. If you want to look at the files or download the current state of the project, you can use the code button and download the repository as a zip file. And if you are used to working with Git, you can also clone the repository. The modules folder contains the main functional modules, MM-Base, MM-Air and MM-Try. Each module has its own files. For example, MM-Base contains its BOM, electronic files, firmware and mechanical files. System parts contains shared components that are not assigned to one specific module. And that's the current state of MM-Fan Gen 1. Thanks a lot for watching this first devlog. The project files are available on GitHub, so feel free to take a closer look, download the files and build your own version. Have fun building it, and if you do, please build carefully and responsibly. If you have questions, ideas or suggestions for improvement, leave them in the comments. I would really like to hear your feedback. And if you enjoy the video, leave a like and subscribe to follow the next steps of the project. See you in the next one.